Hey, everybody, and welcome to Statistical Methods Final Exam Review, really Exam 3, which is over Chapter 7, Chapter 8, and Chapter 9. As always, if you are in our online resources page, obviously you know where this video is at because you're watching it, but under Statistical Methods, you come in here and you will see Test Review Material. This one is about version A. And as we record this, we are creating the solution guide for version A, and the video will be posted once this review has concluded. There are 25 questions total on this. Some are multiple choice, some are fill in the blank, just like all the other previous exams. Do I have any questions before we go forward? All right. Here we go. So I will be using StatCrunch throughout this to help me out since we all have access to that. If you are curious about the TI-84, just ask and I can kind of tell you and walk you through the steps that you need if you're using a TI-84. So if you are using a TI-84, I'm more than willing to talk about it, but I want to focus in on the StatCrunch. I think it's more user-friendly. So we got question number 1 here. And okay. So there's no data with it. It's just 3 questions, multiple choice. So it says in 2017, the Gallup poll surveyed 1,021 adults in the United States and found that 57% supported a ban on smoking in public places. So part A says, identify the population. So you got A, B, C, D, E, or F. Who is the population? What do you think?
Would it be D?
D. The D says the population is adults in the United States. I like it. And that is correct. Because up here, your population is just basically taking out the number. Who are we talking about? Who did we talk to? Not what they support or anything, but it's who we talk to. And so in this one, it is definitely D. The population is the adults in the United States. Okay. So B says identify the sample. So again, you got that A, B, C, D, E, F. So who did we sample? E. Very good. E wants, basically, when you talk about the sample, it wants to know how many people did you talk to? And E is the one that tells us how many people we talked to. We talked to 1,021 adults. And in part C, what is the parameter? What is the statistic, in other words? Parameter and statistic. Again, we got A, B, C, D, E.
C.
C. Anyone else? And I agree with C. So the parameter and the statistics is talking about what we were looking at. Okay. So in here, if we scroll back up, this survey was all about supporting a ban on smoking in public places. So since this is a sample that we took right here, because it is a survey of 1,021 adults, the parameter, oops, too far, would be about the percentage of adults who support smoking bans, which is what C says right there. And then the statistic is actually the percent that we found from our sample. So C is absolutely correct. Any questions on number 1? So it was taking us back to those basic ideas. What is a statistic? What is a parameter? What is the population? What is the sample? All that stuff that we kind of talked about all the way back in chapter 1. Everyone good? Makes sense? Okay. Question 2 is similar again. We're going to do the same thing. So in 2017, the Pew Research Center polled 3,930 adults in the United States and found that 43% reported playing video games often on some kind of electronic device. So identify the population.
D.
D. I love it. Again, we're talking about adults in the United States. Okay. Adults in the United States. Be careful. C can be misleading because it talks about people. People includes children. So that's why we don't select people. Okay. Because this is specifically about adults. That's what it says right there after the 3,930. All right. What is the sample?
A.
A. I love it. Because that's how many adults we talk to. That's how many adults we talk to. Perfect. Okay. And C, what is the parameter? What is the statistic?
Would it be B?
B, so you're saying the parameter is the percentage of all adults who play video games. The statistic is the 43% of the sample who plays video games. And I'm going to agree. Yay. I love it. Because our survey was all about finding out those who play video games. And it's being reported out as a percentage rather than a total. Because I know that there is one piece in here, right here, if you're looking down here, the parameter is the number of all adults who play video games. The statistic is the 1,670 adults who play. This is technically correct, but with the information that they gave us up above, it's all about the percentage that they were after, which is why B was the better answer. Because it goes along with what was originally reported out. Okay. So always make sure that you're carefully reading these, because they do throw in some answers that are technically correct, but not the better answer. All right, we're working our way through. We're doing great. So the website, scholarshipstats.com, collected data on all 5,341 NCAA basketball players for the 2017 season and found the mean height of 77 inches. Is statistic. Also identify the population and explain your choice. So what your choices for that drop down menu, just like before. So the number 77 is a what?
Parameter.
Oh, now you're back live. What is 77?
Parameter.
It is a parameter. How did you know that?
Because when you look at the question, it says that the data was collected on all the basketball players for that
Yes.
season.
All basketball players. That's the entire population. So that is a parameter. Good. So the population is all NCAA basketball players, all basketball players, all NCAA basketball players in the 2017 season.
The last one.
The last one. It's very specific. This is a very specific population. It is all NCAA basketball players in the 2017 season. And last but not least, because blank. They are the entire group of interest. They are the whole group from which the 2017 sample was taken.
That one.
I would say the first one because there was no sample since it's a population, right? So
Very
the
good.
entire group of interest.
I agree.
Yes. Yeah, you got to throw out the second one because it mentions sample. This is not a sample. Okay. This is not a sample. This is the population. So yes, good thinking. So they are the entire group of interest. Everyone okay on this one?
Yes.
All right, here we go. Let's jump into number 4. Okay. So in number 4, it says, make the two given tables into one table by combining men for capital punishment into one group, men opposing it into another, women for it into one group, and women opposing it into another. The student who collected the data could have made the results misleading by trying persuasion more often on one gender than the other, but she did not do this. She used persuasion on 10 of the 20 women, which is 50%, and 15 of the 30 men. Okay. So the first thing we need to do is make a table. So for capital punishment, and I'm creating the table on my little piece of paper here. Against capital punishment, and we've got men versus women. So men, women. So how many men are for capital punishment?
20.
20. Because you take the 8 and the 12 and combine them together. How many men are against capital punishment?
10.
10. Take the 7 and the 3. How many women are for capital punishment?
7.
How many are against?
13.
So this is what your table should look like. 20, 7, 10, 13. So that's part A. Any questions on that one?
No.
Good. All right, part B, let's continue on. Let's look at more of this. So it says, what percentage of men supported capital punishment? What percentage of women supported it? So of the 30 men, what is the percentage?
I would say that is 62.5%.
62.5%.
I have 66.7.
Yeah, I have 66.7 as well.
Why is it 66.7?
Because you have to divide 20 by 30 by the
You
total.
got it. You got it. Because we're talking about the percentage of men. Okay, not out of everybody, but just among the men. So within the sample of men, you had 20 out of 30, which is 66.7%. And good that you were reading that little piece right here in the parenthesis, round to 1 decimal place. Because technically it's 66.6 repeating. Okay. What about the women?
35.
How did you get 35?
You divide the ones that are for capital punishment over the total, which is,
Which is?
7 over 20.
And that comes out to 35 even?
Yeah.
And so since I want to put 1 decimal place, it'll be 35.0. So this was men, this was women. Show you on my little piece of paper. So this is exactly what we just talked about. To get the men, you take the 20 divided by 30 because there are 30 men. There's our answer. Take the 7 divided by 20 because there are 7 women, 4 all over 20 because that's total of 20, and 35.0 because it does ask for 1 decimal place. So I like to kind of make sure that I have all my decimals accounted for just in case. It shouldn't count it wrong if you just put 35%, but I always like to, double check. All right, so part C. On the basis of these results, if you were on trial for murder and you didn't want to suffer capital punishment, would you want men or women on your jury? So part C.
Woman.
Okay, so a jury of women
And then higher.
would be preferable, as a blank percentage of them are not in favor of capital punishment.
Higher.
You got it. A higher percentage of them are not in favor of capital punishment. Okay, so definitely make sure that you read this last sentence. I know some people might say lower because the women had the lower percentage. But remember that this percentage is based on those that are for capital punishment. So in our question, it says, well, think about the percentage of those that are not in favor. It would be higher for the women. So definitely make sure that you read your question all the way through, because sometimes they like to throw that different wording in there. Okay. All right, good work. See, not so bad. We're already at question number 5. And so, question number 5 and question number 6 are actually the same question. So if you get question number 5 right, I hope that you can get question number 6 right. Okay.
Number 6 isn't the same as number 5 on this.
Wait, I know, but when you get into the exam, I'm telling you right now, at least for the Poinciana students, they're the same question. All right. So if a rifleman's gun sight is adjusted incorrectly, he might shoot bullets consistently 2 feet to the left of the target's bullseye. Okay. Just so you know, each ring is a distance of 2 feet. Okay. Because the whole diameter of the target is 8 feet. Actually, sorry, wait a minute. 1, 2, 3, 4, 5. Yeah, actually, each ring is about a distance of 1 foot. About a little less. So which target below shows the bullet holes consistently close to 2 feet left of the bullseye?
B.
B. See, not that bad. And what does that mean? Does it show a lack of precision or bias?
D,
C.
both bias and lack of precision.
Both? It's not both, I can tell you that.
Bias
What?
C.
The bias C. Why, Ruben? Talk
Because,
to us about that.
because he has precision. He's constantly hitting it 2 feet, but very accurately. 2 feet to the left.
You got it. He has the precision. Precision is meaning that your bullet holes are close together. Okay. Hitting the bullseye means that there is less bias. It means you're doing things correctly. So because he is consistently 2 feet to the left and his bullets are come together, that's good precision. He has a lack of bias.
Professor, just so I understand. So bias is because he's not hitting the bullseye, right?
Correct.
Okay.
Means that in the survey, his questions have some probably bias in there, or there might be some sort of persuasion this person is using, things like that. If you're thinking about it in a survey type, you know, something is skewing your results always to this side. Make sense? All right. So draw a sketch of a target that is both unbiased and precise.
D.
Yeah, that's going to be D. When you are hitting the bullseye every time, you are unbiased and precise. Cool beans? All right. Moving on. So, number 6, a recent poll found that 654 out of 1,030 randomly selected people in a particular country felt that colleges and universities with big sports programs place too much emphasis on athletics over academics. Assuming the conditions for CLT are met, so we don't have to worry about that, here's some information that a mini tap output provided us. Complete the following sentence for part A. So I am 95% confident that the population proportion believing that colleges and universities with big sports programs place too much emphasis on athletics over academics is between blank percent and blank percent, round to 1 decimal. So what's going to go in my first percentage?
I would say that it is 60.6 and 66.4.
Oh, he's giving me both. This is going for the gold. So the other one is what again, though? Sorry, I was writing down the first one.
Sorry for that. 66.4.
Perfect.
Which
Because
is
you,
the interval.
yeah, that is our interval. So up here, they're giving you the decimal of the percentage. So you have to convert that. Okay, so moving those decimals to get the 60.6% and to get the 66.4%. Perfect. Now, part B. So part B's got a couple of choices here. So part B, suppose a sports blogger wrote an article claiming that the majority of adults in this country believe that colleges and universities with big sports programs place too much emphasis on athletics over academics. Does this confidence interval support that claim?
Yes.
Okay, so that means it's either D or C now.
C.
D,
I agree.
Oh, I heard a C, I heard a D, and I heard an I agree
Yeah, I agree with C.
with C. So yes, it is plausible. It is a plausible claim because the confidence interval contains only values above 50%. Okay. But what about D though? Yes, it is plausible. It is plausible claim because the confidence interval does not contain 50%.
I'm sorry, what was the question?
So you said D, Elaine.
No,
And
I said
then-
C.
Oh, you said C?
Yeah.
Did someone else say D?
No, I think me and Catherine both said C.
Yeah, we all said C.
Okay, sorry, I thought I heard a D in there. Just kidding. And yes, the answer is C. It is C. It is true. Oh, sorry. It is true that the confidence interval does not contain 50%. That is true. But again, the question is, he's saying a majority. So a majority means that you've got to have over 50%. That's why C is more correct than D. All of your numbers have to be above 50 to say a majority. Where in D, I can create a confidence interval that does not contain 50%, but not be a majority. For instance, if my confidence interval was 30% to 40%, doesn't contain 50, but that doesn't mean I'm in the majority. So that's the difference between C and D. So think about these questions. Statistics is pretty much all about the interpretation. So number 7, a quick and easy one. The null hypothesis is always a statement about the what? The sample statistic or the population parameter?
Parameter.
Population.
It is always about the population. Always, always, always. So good. Population parameter. Number 8. In statistical inference, measurements are made on a blank and generalizations are made to a blank.
Sample and population.
That's right. We perform statistics from samples, which are measurements. So we perform measurements with samples and generalizations are made about the population. Nice. Everyone okay so far? Perfect. Moving on. So now we have a hypothesis test. Okay. So a college chemistry instructor thinks the use of embedded tutors who work with students during regular class meeting times, will improve success rate in the introductory chemistry course. The pass rate for introductory chemistry is 58%. The instructor will use embedded tutors in all sections of introductory chemistry and record the percentage of students passing the course. State the null and alternative hypotheses in words and in symbols. Use the symbol P to represent the passing rate for all introductory chemistry courses that use embedded tutors. All right. So part A, state the null hypothesis in words. The proportion of students who pass introductory chemistry is blank. Equal to. That's right. That null hypothesis is always about the equal to. State the null hypotheses in symbols.
The first one, P equals 0.58.
I'm so proud of you all. Now it's all about the alternative, the ha. The proportion of students who pass introductory chemistry is blank.
Different from.
Greater than.
How do you know it's greater than?
Because it states in the question that the professor thinks that the use of embedded tutors will improve the success rate, which
Right
means
there.
it's be greater.
Yeah, right here. Will improve. He doesn't want it to go down in that first sentence. This is his hypothesis. He thinks it's going to improve. So that would mean that it's going to be greater than. He is hoping to increase those results, which leads us to D. In symbols, which one is it?
First one.
The first one. P is greater than 0.58. Any questions on number 9? Does that make sense? Okay. Ruben, you good on that?
Yes, yep, I missed that one word because 2 words there.
Yeah, no worries. Just want to make sure that we catch that.
Yes.
All right, here we go. According to a 2017 report, 36% of adults aged 18 to 29 had student loan debt. Suppose in a random sample of adults from this group, 77 out of 200 had student loan debt. So give the null hypothesis and alternative hypothesis to this test. They've given you a picture of the results. So this should also help inform you about the HA, because they don't specifically state up above what their theory is, but the picture lets us know what HA should be about. So part A, what is the null? P
So-
blank blank.
P equals, I don't know if this is right, but 0.36.
0.36. Good. P equals 0.36 because that's what was reported about the population in 2017. What is the HA then?
P,
Not equal to
Yeah.
0.36.
How did you know it was not equal to?
Because it doesn't say anything in the sentence, and then the graph shows us that it's two-tailed.
Correct. It's really the two-tailed from the picture. Anything that is two-tailed is the not equals. Perfect. Good work. So there's part A. Here's what it looks like. P equals 0.36. P not equal to 0.36. Good work. All right, part B. So report the test statistic. Round to 4 decimal places.
that's the one that is given in the table. So 0.7366.
Done. Cool, cool.
Yes.
All right. Guys are doing awesome. Keep it up. All right. Moving down. Number 11. Go too far. Suppose researchers are testing people to see whether the rate of use of seatbelts has changed from the previous value of 84%. Suppose that in their random sample of 500 people, they see that 433 have the seatbelt fastened. Okay. Which of the following figures is the correct p-value for the testing of the hypothesis that the proportion who use seatbelts has changed?
I would say B.
B. What's giving it away?
The two tails or the two sides, because it's going to allow for us to see the difference or the change, whether if it was good or not.
Okay, that's right. They're not saying that it has increased. They're just saying that it has changed. And is changed is another way of saying is different. And whenever you run into that is different or has changed, that's a not equal to. Okay. If they want to talk about an increase or decrease, that's when you're dealing with the one tail. So B is absolutely correct. B is absolutely correct. So you've chosen the correct picture. So in part B, obviously, we already know the first answer, graph blank. So it is graph B. Is the correct figure because the alternative hypothesis should be blank.
Two-sided.
Mhm. The test is to see if the proportion has blanked.
Changed for better or worse.
Changed for better or worse, just like what Lewis said. They didn't ask if it improved. They just said, has it changed? Awesome sauce. All right, number 12. So a researcher carried out a hypothesis test using a two-tailed alternate hypothesis. Which of the following z-scores is associated with the smallest p-value? Explain. Complete parts A and B below. So which one of these scores will give us the smallest p-value?
B.
Why B?
Because the bigger the z-score, the smaller the p-value will be.
Correct. Yeah, because remember, your z-score is about how far away you are from the middle. The further you away from the middle, the smaller those p-values out there is going to be because there's less area to think about. So, and with Lewis's explanation, which answer is it for part B?
B.
B. B again, because of just what I said. The z-score furthest away from 0 has the smallest tail area, thus the smallest p-value. Good job. And ladies and germs, we are pretty much now halfway through this exam. How you feeling so far?
Great.
Awesome. So 13, when a person stands trial for murder, the jury is instructed to assume the defendant is innocent. Is the claim of innocence an example of the null hypothesis, or is it an example of the alternative hypothesis?
Would it be A?
Yeah, agree. I mean, I think so, yeah.
You think so? Yeah. So
I mean,
Elaine, you're gonna, yeah. Or
I believe
Lewis?
because it's like you have to prove they're like that they're guilty. It's not like they're guilty and then proven innocent. So yeah,
You are
it's like
correct.
a null hypothesis. Yeah.
Yeah. As a jury member, your null hypothesis is they're innocent. It is the burden of the prosecutor to prove that you are guilty if you are on trial. So the null hypothesis is you're innocent. The alternative is you're guilty. Make sense? Yes, perfect sense, Mr. Armstrong. I'm never going to be on trial. Good. I'm glad you guys are not going to commit crimes and be on trial. Thank you for that. All right, number 14. A research company published survey results from 2 random samples. Both samples were asked, have you listened to an audiobook in the last year? Use the accompanying results from the study to complete parts A and B. So part A says, find and compare the sample proportions. that have listened to an audio book from these two groups. All right. So it says the sample proportion of the 2015 subjects that listened to an audiobook within the last year is blank. And down below it says round to 4 decimal places. So are we given a decimal or a percentage?
Decimal.
Yes, you're given the decimal. I know it's not a percentage because there's also no percentage symbol out here. So how do we find that? How do we find that first blank? What are we going to do?
You divide the given for the 2015, the given yes by the given total. So 230 divided by 1889.
Okay, 230 divided by 1889. And to 4 decimals.
0.1218.
Perfect. So that's the 2015. And then the sample proportion for 2018 subjects that listened to an audiobook within the last year is blank.
0.1820.
Well, how'd you get that?
I divided 363 by the total.
Divided by the total, which was 1,995. Perfect. So again, this is what it looks like as far as the math goes. The total in 2015 that said yes, divided by the total of people we talked to. And here's the total that said yes in 2018, divided by the amount of people we talked to. And there's those percentages rounded perfectly. Okay. But we're not done. Oh, sorry, we are on 14, not 15, Mr. Armstrong. So in here it says the sample proportion, and this is still part A. The sample proportion for 2015 is blank. The sample proportion for 2018, less than, greater than, equal to.
Less than.
Less than, it is a smaller number. You are so smart. S and Marty. All right, part B. Are a greater proportion listening to an audiobook in 2018 compared to 2015? Test the hypothesis with a great proportion. I think that's supposed to be greater proportion of people listening to an audiobook in 2018 than in 2015. Use a 0.05 significance level. Consider the first sample to be 2015 and the second sample to be 2018. So right there, they're telling you who is P1 and who is P2. Okay, so which ones down below represent the correct hypotheses?
F.
F?
Yes.
No, it is not F.
A.
It is A.
Oh, yeah, because it's B2. Yeah, I'm sorry.
Yes.
Yeah.
Yes. This is why you got to make sure that you know who is who. Your P1 is all about 2015. Your P2 is all about 2018. And up here it says, test the fact that the greater proportion of people listen in 2018. So when you're looking at the ha, let me flip over to my piece here. We're saying 2018 is bigger than this guy. But if we have to go in order, the P1 to the P2, if P2 is bigger, it means the crocodile wants to eat it. Remember the little crocodile with the teeth eating the larger number, all that good stuff back from elementary and all that. So this is A. Okay. But Louis, I like that you did say the other one, because normally a good rule of thumb is that we put our current data first, and then we have our older data second, which would have been F if that was true. So just make sure that you read. All right,
Yeah.
so now we need to go in and we need to find some information. We need to find the z-score. We need to find the p-value.
And Professor, I had a question about the signs, because I always get confused with the equal sign, like the not equal to sign. What are the keywords that you said that we are always going to see that are going to basically allow us to see that it's going to be not equal to?
So not equal is when they're saying that they are different or things have changed. They're not saying it's improved. They're not saying it has diminished. You know, look for those words where it just says it's different. If they say it's different, that's a not equal to.
So like the chemistry example that they,
Yes.
yeah.
Yes.
I mean,
He's
it would be like the
it-
seatbelt more, I think, the one that it was like two-tailed.
in the chemistry example, remember, he said that it improved.
Yeah,
So right there, that's not a two-tail. He's saying it's getting better.
it would be more like the seatbelt one, which was like
Yes,
they wanted to determine whether it was worse or better.
correct. In the seatbelt one, they're just saying it has changed. Well, they're not saying for the better or for worse, so that's why it's a two-tail. All right, so we're going to go into StatCrunch. We're going to run our data. All right. And is this data or is this a summary that we have in here?
Data. I mean data. Sorry.
This is data. Try again. Up here, this is basically going into your summary. Okay. Data would be if we have everybody listed out. Does that make sense? This is actually a summary of information. Okay. So let's go into StatCrunch. Stat. And what are we running? A t-test or a z-test?
T-test.
Say it again.
A t-test?
It is not a t-test.
Z-test.
This is a z-test. Z-tests go with p's, proportions. Z-tests go with the means. This is not about a mean. It's about a proportion, p. So z-stats, this one sample or two sample? It is two. So we're going to go in here with summary. Just kidding.
Isn't it in proportion stats?
Oh, yeah. Sorry. Yes. Two sample with summary. Yes, there it is. Sorry, I went to the wrong place. So in here, our number of successes. Well, let's go back and just make sure that we get this information. How many successes?
230.
230. Okay. Out of how many?
1889.
1889. Perfect. How many successes for 2018?
363.
63. And out of how many?
1995.
Correct. And because we're saying they're equal, don't change this. Now my sign, which sign am I going to use?
Less than.
The less than. Compute. Okay. So now you're going to report your Z statistic. So let's make sure we know what we're doing here. It says 2 decimals, and then the p-value will be 3 decimals. All right, so that's good to know. So the Z value, 2 decimals.
5.21.
Careful. Negative
Ah,
5.21.
not what I said.
No, you said a positive. Or if you said negative, I didn't hear it.
Yeah, I thought I said, it's okay, whatever.
It's all right, no worries. And then what is the p-value?
0.000.
0. And they want all those zeros. They want all those zeros. Okay. So we got our z-score. Negative 5.21. We got our p-value. And then now we're on to the interpretation. So in here, it says, since the p-value is blank, greater than or less than the significance level.
Less than.
Less than. The significance level of alpha equal to 0.05, blank the null hypothesis.
Yeah.
Say it again.
Reject.
Reject. We don't want it. Reject the null hypothesis that they are the same. There is blank evidence to support the claim that the proportion of people in 2015 that listened to audiobooks in the last year. Okay, let's just go with that first one before we continue with the rest.
Sufficient.
Sufficient. Yes, we have evidence. Sufficient evidence to support the claim that the proportion of people in 2015 that listened to audiobooks in the last year is blank. The proportion of people in 2018 that listened to audiobooks. Greater than, different, less than?
Less than.
Less than.
Yes. We have enough evidence to support our alternative hypothesis. Any questions on number 14? All right. 15. A study of all students at a small college showed a mean age of 20.5 and a standard deviation of 2 years. Complete parts A and B. So part A. Are these numbers statistics or parameters? Explain.
I would say that they are parameters. So
Why?
they, because it's saying that all students at a small college. So a
Yeah,
mean,
right.
so all.
So which one would it be? A, B, C, or D?
I think it's C.
You're
Yeah,
correct.
C.
Because C states that they are parameters because we are talking to everybody. It's not a sample. I didn't survey anybody. I talked to everybody. This is a census, so to speak. All right, part B. Let's label these numbers. So the 20.5 is which label or symbol?
Mean.
Yes, it is mean, but which symbol is it?
X
The
bar.
one-
The X bar? Nope.
The one that looks like a
New.
U.
The one that looks like a U. Mew.
I don't really know the name, but yeah.
It's okay. Think Pokemon. Mew. So the 20.5 is mu. Then who is the 2?
The O with the
It's
thing.
the sigma. Yeah, the O with the little line across the top. So looking at this, just to show you. So mu, the U, is the 20.5. So lowercase sigma, circle with the line, is your standard deviation. Remember, Greek letters go for parameters. English letters like X and S go for statistics.
Professor, there is a question from Brooke in the chat.
What's up,
It-
Brooke?
Yeah, and it says so if it's less than fail to reject, if it's greater than reject, I think she's referring to the
You're
p-value.
talking to the hypothesis test. Yes.
Yeah.
Brooke, whenever your p-value is less than alpha, you have to reject. When your p-value is greater than alpha, you fail to reject. Always.
Thank you.
No worries. All right, so number 16, a survey of 100 random full-time students at a large university showed the mean number of semester units that, oops, hold on, I got someone coming in. There we go. Showed the mean number of semester units that students were enrolled in was 15.6 with a standard deviation of 0.9 units. So again, same as what 15 was like. So are these numbers statistics or parameters? And explain.
I would say definitely statistics.
Definitely statistics. You sure, Lewis?
Yep. So it would be B because it's not all students. It's a random sample of students within the university.
You got it. We're not talking to every full-time student. We only talk to 100 of them. Okay. So that's definitely not a population. It is all about statistics because it is just a sample. Okay. Perfect. So let's talk about those labels again. Then the 15.6, which they said represented the mean, is which symbol?
This time it would be X bar.
Yes, that's the X bar.
And then
Then the standard deviation of 0.9 is which symbol?
S.
Yes, because this is a sample. This is a sample. So jumping back into this again, this was all about a population, hence the Greek letters. This was all about a sample, hence the English letters. All right. Everyone good on number 16? $17. Whoops, wrong one. Well, let me do this real quick. If you've noticed, there really isn't a lot of math on this. You know, it's really knowing about those concepts. You guys are doing great. All right, so it says the distribution of scores on a certain exam is n parenthesis 30 comma 5 parenthesis. What does that mean? That n parenthesis 30 comma 5 parenthesis?
A normal distribution.
A normal distribution. Good. And what does the 30 represent?
The
Yeah.
mean.
The what?
Mean.
The mean. And the 5 is?
Standard deviation.
Good. Good, good, good. Okay. I'm just writing that information down because we're going to use that. Which means the exam scores are normally distributed with a mean of 30 and a standard deviation of 5, which is what Elaine just told us. So we're going to complete parts A through C. So the first thing they want us to do is sketch a curve and make sure that we label it with what we know. All right, so let's do that. So we're going to sketch our curve. Who always goes in the middle?
The mean,
The mean. So what number is right here in the middle then?
30.
Perfect. And then when we come out here to 1 standard deviation, who's going to be the number up top?
35.
How'd you get 35?
Because standard deviation is basically how away you are from the mean. So you just add 5, and if you are in the other point, like in the other direction, you subtract it.
Oh, I subtracted going this way, huh? So where are we at here then?
25.
25. Yeah, that standard deviation is basically how you're going to move along your little curve. So then as we keep going up, so +2 standard, +3 standard, -2 standard, -3 standard. Let's fill in the rest. So +2 standard, where are we at here?
$40.
40. And +3.
$45.
-2.
$20.
25,
-3.
15.
15. So this is the picture we need to select. And again, this isn't really new for us. This is really going back to what we did in chapter 3. So let's go back to our exam real quick, review. So is it A, B, or C?
A.
You got it. So the picture we created was really graph A. All right, so part B says, what is the probability that a randomly selected score will be greater than 35? And it says we can use the empirical rule on this.
13.5.
13.5. Well, let's go and take a look. So it says greater than 35. All right. We want to be greater than 35. Stuff is moving around on me. Don't do that. Hold on 1 second. There we go. So greater than 35 would be from here to the right. So we're 1 standard deviation, and that's what our picture looks like. So how much is that area? And Ruben, it's not 13.5. But I like where you were going.
16.
16.
16.
Okay. So let's walk through this and let's check. Okay. Remember that right here, this is halfway, right?
Mm-hmm.
So how much data is up here then?
50%.
50%. Now, how much data is between these two?
13.5.
That's 13.5 there. So remember that when we're midway here at mu, this represents 50%. Right?
Yes.
And just as what Ruben said, between here, this is how much?
13.5.
Are you sure on that?
Where I'm not.
We're
where we-
between mu and 1 standard deviation. How much is this entire bar right here?
34.
34. How'd you get 34?
Because 1 standard deviation is 68 and you divide it by the 2 segments and 34.
That's right. Remember, between 1 standard deviation,
Yeah.
both on the positive to the negative, that represents 68% of your data. We only want half of that.
16. You're right.
So that's 34%, 34%. So all I really need to do is take 50 minus the 34. And how much is that?
16.
16. Make sense?
100%.
Yes.
Perfect. All right, let's go back. Let's make sure that we answered this entire question. So it says write it as an integer or a decimal. So we got 16. So all good. Okay. Then part C is after the graph. So which one of these graphs represent what we just did?
B.
B. Perfect. So part C is B. And again, I kind of showed you what that looked like with my little makeshift graph right here when we were talking numbers. Good job. I love it. Definitely got a little bit of math on that one. Number 18, again, a lot like what we just did. So in this one, it says the distribution of scores on an exam are n with parenthesis 30 comma 10 parenthesis, which means the exam scores are normally distributed with a mean of 30 and a standard deviation of 10. So part A, again, we are after that same graph. Easy thing about this is, I mean, there's really a small difference. The only thing between these two problems that's changed is that this was a 5. This is now a 10. So it's pretty much going to be the same curve, except we'll be counting by tens. Let me make that dotted.
So it would be 30 in the middle and then just add and subtract 10.
You got it. So I'm just writing some things up real quick as fast as I can. So that way I don't bore you. Solid. Not a solid line, Mr. Armstrong is dotted. So who goes in the middle then?
30.
30. One standard deviation above. Oh, you can't see it.
40,
40. The next one.
50,
Next one.
60,
Yay. All right, one standard deviation below.
20.
Next.
10.
Next.
0.
Perfect. And then the question is,
C.
which graph is it? And you said C.
Yes.
I agree. All right, so part B. Find the probability that the randomly selected score will be between 10 and 50.
95%.
Agree.
Got me writing down between 10 and 50. So again, we can use that, empirical rule. Name was almost slipping me. We just talked about it. So when we're between 10 and 50, if I kind of make that makeshift graph again, that's horrible. Oh my gosh, Mr. Armstrong, what are you doing? So this is mu. 10 was down here at -2. And 50 was up here at a +2. So we're talking about this. And so you said it's how much?
95.
95. I love it. Because that is the percentage that is between two standard deviations from the empirical rule.
Yes.
Because the empirical rule, what is that empirical rule? What are the percentages?
68, 95, and then was it
99?
99.7?
99.7. That's right. So all because of that empirical rule, that entire distance is that 95. All right. And then
Professor, so if we put in the exam, let's say that in the exam, this particular problem was representing 3 standard deviations, would we have to put 99.7? Or if we put 99.0, for example, will we get it wrong?
I put the 99.7 because that's what the empirical rule says.
Yeah.
But you know, I mean, the big thing is make sure that you read those, you know, that small information, you
Yeah.
know, the stuff in the parentheses. So again, on this, we go back. Part C is going to be just like before. Which picture is it?
C.
C. C, I knew you could do it. Get it? All right, 19. Here we go. The mean age of all 2,558 students at a small college is 22.5 years with a standard deviation of 3.1 years. And the distribution is right skewed. A random sample of 3 students' ages is obtained, and the mean is 22.8 with a standard deviation of 2.6 years. Let's complete the following. So first, part A. It wants to know who is mu, who is sigma, who is x bar, who is s.
So the U looking one, that's 22.5. And the O with the thingy is 3.1.
All right. So mu is the U looking one. That's our mean. And the O with the thingy is lowercase sigma. And that's the 3.1 because those two are about our population. All right. Then who's X bar?
22.8.
Good.
And then
That's about our
2.6
sample. Keep going.
2.6 is
And the
our
2
standard deviation.
Standard deviation of our sample. Good. So again, if you didn't catch all that, this is what it looks like when filled in. So our two population parameters, mu 22.5, sigma 3.1. X bar is our mean, which is 22.8 of the sample, and our standard deviation of the sample is 2.6. All right. Continuing on. B.
Is it?
So is mu a parameter or statistic? I kind of just answered this for us. What is mu?
Parameter?
Parameter. Because it is found from the blank.
Population.
Population. You got it. Good work. C. Are the conditions for CLT met?
Yes.
Yes. What do you remember? What are all the conditions?
Random, independent, large population, and I always forget the other one.
I think it's C. So no.
Oh,
What did you say? I couldn't hear you.
Catherine says she thinks it's C.
Can I see the question again? Just to
Yeah,
like
it's right
read
there. The question is, are the conditions
I mean
met?
the one that has the information.
Yes, right there. There you go.
Oh, agree. I agree. Same. Yeah, the sample is 3 students, so it's too small. Yeah.
Too small. Are you sure? All right, well, let's double check. So random and independent. Is this random and independent?
Yes.
Yeah, our sample is random. It says random. Okay, it is definitely independent because one student's age does not affect another's. So random and independent are met. Now, here's the question. The next piece is about the sample size.
It
The
is.
next piece is about the sample size. Is this a-okay with a sample size of 3?
I would say no because we talked about. I remember something about like 25 or normal distribution. So.
But that's for means. Does that still apply to this?
No. I don't
No?
really.
Yes?
I just know it's too small, but I just like don't remember the particular rule for it.
Wait, isn't it 10 times n?
10 times n. So the
That's
question is, are we dealing with proportions here or are we dealing with means?
means.
Means,
Means.
okay. So Lewis, when we're talking about that sample size,
So it is a
the mean-
25.
say it again.
So we would apply the 25 then.
We would apply the 25 here. So this one isn't about the n and all that with the greater than or equal to 10, because remember, that's all about proportions. This one's all about means. So this is where the CLT changed and it went over to that. Is our sample size 25 or more, or is it normal? So let's just answer this first question. Is it normal?
No.
No. How do you know that?
Because it doesn't say it's normal.
It doesn't say it's normal. It says it's what?
Skewed, right skewed.
Right skewed. Okay, so we can't rely on normal. So we have to rely on the 25 or more. Do I have 25 or more? No. So which one do we select then? A, B, C, or D?
What Catherine said. So see.
What Catherine said, you bet. We do not have a large enough sample. We do not have a large enough sample. So down in part D, what would the shape of this look like for a sample of 3 students then?
A.
A. And I totally agree with A, because it should look like what your regular distribution look like. What your population looks like. It should mimic it. Very good. So it'll be right skewed. Any questions on this one? All right. We're almost there. We're at number 20. Yay! All right, number 20, confidence intervals. So the median undergraduate grade point average for students accepted at a random sample of 12 medical schools in the country was taken. I think that's supposed to be the mean, not a median. The mean GPA for these accepted students was 3.55 with a standard error of 0.06. And that standard error, remember, that's a lot like our standard deviation. The distribution of undergraduates' GPA is normal. Complete parts A through B. So it says determine which, or decide which of the following statements worded correctly for a confidence interval. Fill in the blanks in the correctly worded one. Explain the error for the ones that are incorrectly worded. Select the correct choice below and I feel like there is a lot that's going on here. Oh yeah, we've got more than one direction here. So the first one is we're going to select. Okay, I see what they did. Sorry, I'm not the one that created this, but I see what was done. So there's 2 parts to this part A. So in part A, we're going to find the correct one and select it and fill in the blanks. And then after that, we're going to explain the error and the ones that are incorrect. Okay. Round to 2 decimal places when needed. So for part A, which one represents the confidence interval?
I would say we are 95% confident that the population mean is between blank and blank.
You got it. So that is C. We are 95% confident that the population mean is between blank and blank. So what are the blanks and blanks?
Don't we have to do calculations on StatCrunch, or
Nope.
we just take the standard deviation with the mean?
You have everything you need.
So would we take the mean GPA, the 3.55, and just add the 0.06 until we get to like the two standard deviations
Mhm,
and subtract it?
mhm. So remember that we had a formula for this, finding it by hand, which was really quick and easy. Okay, so you know the standard error, you know your confidence level. Okay, our confidence level is 95%. Our formula for doing this looks like this. Let me switch my view here. So to fill in our blanks, oh, sorry. We have a formula that says we're going to take our X bar and we're going to add and subtract M. Okay. Now remember, M represented the margin of error. And in order to find M, we're going to take T star times the standard error. Okay. Everyone okay for me so far? So remember that T star here is all about degrees of freedom and our confidence interval. We had a whole chart that had that information on it. All right. Any questions so far? So I need to bring up that chart for us. Let me do that real quick. Oh, man.
Professor, just to be sure, this we could do on StatCrunch, right?
I think we can, but let's just do it by hand real quick, and then we'll explore StatCrunch real quick. I'm pretty sure we can do this in StatCrunch, but off the top of my head, from what I remember with this one is they are really giving us everything that we need.
And I think in the homework it said that we have to do it without
hand?
like, yeah, I think so.
In the homework, it was telling me to do it with technology, and I was trying to, but I didn't understand how to do it.
Okay.
Kept getting the wrong answer.
Yeah, so I had to do it another way using technology too. But yeah, let's see.
It's all right. So let's walk through this by hand, and then we'll go to the technology and check it out real quick too. All right. Okay. Give me 1 second. I'm getting my canvas loaded up real quick so I can go to that T distribution chart that we talked about. Come on, canvas. Modules.
Are we given the T distribution chart on the exam?
If you need it, it should be there, and I will double check.
Because it wasn't there for our homework, I don't think.
But again, in your homework and things like that, for me, remember, I gave you the T distribution chart out in our class.
Mm.
It was in the home. I when I was doing the homework, there was I remember that there was a link to access the chart.
Yeah.
In the homework, there was like a where you click on view examples or something. I think there was a link to see the table with the T values.
All right. So here we go. All up in it now. T distribution table. Let's open it up. So to find our T star, there it comes. To find our T star, we've got our confidence level up here. So we're in the 95% confidence. So these are our T star values. We just got to figure out what the degree of freedom was. And how do I figure out the degree of freedom again?
N-1.
N-1, right? So what is our sample size?
12 would be 11.
You got it. So our T star so I'm just writing something down on my notes. Level. All right. So our T star then, coming back to this, is at 11 and the 95%, which is 2.201. This is our value right there. So what we just talked about, what we just found was our T star that we're going to be using. So you take the degrees of freedom, which is 12 minus 1, which gives us 11, because the degree of freedom is your sample size minus 1. Our confidence level is 95%, and these are the two that lead you to that number on our chart. So now to figure out M, all I need to do is take 2.201 times our standard error, which, what was our standard error? 0.06. And that will be the M value. So go to your calculator for me real quick and find that M value. Do not round it.
$0.13206.
0.13206.
Did I do it wrong?
What is the 206 part was what threw me. So 0.13206. So this is the M value we're going to add or subtract to our mean. So we're going to take our mean of 3.55 and add or subtract 0.13206. And that will give us our lower and upper bounds. And our directions again said round to 2 decimal places.
We subtract once or 3 times.
Just once.
So it would be 3 point, what was the decimal places?
2.
So it would be 3.42 for the first one, and the second
Okay.
one would be 3.68.
$3.68.
Mhm.
Okay.
Yeah.
So these are what go in the blank on part C. Everyone okay so far? So let's talk how StatCrunch can help us. Okay. So if we go to StatCrunch, go to StatCrunch, we go to T-stats because we are working with means. We're doing a 1 sample, and this is with a summary because they gave us all the information we need. What's the sample mean?
3.55.
Standard deviation, sample size,
12.
and you're doing a confidence interval. Same answers.
No, it's not.
Well, yeah, extremely close though.
But the exam would count it wrong because that's what I was doing for the homework and it kept counting it wrong.
Hmm,
Yeah. So
42,
Interesting.
3.68. That's substantial.
Would we have to change then the 0.95?
let's go back and look at this because they shouldn't have been different. T-stats, it's a one sample. It is with summary. Let's make sure, actually, let me go back to this. Let's make sure we got everything in correctly.
Professor.
That's into the standard deviation and we're given the standard error.
Yeah.
Which should be essentially your standard deviation.
Professor, what I did to like change it. So the only thing that I needed to change was the standard deviation. And so I did 0.06, so the standard error, square rooted by the.
Oh, you went back. Okay. Okay. I get what you're saying. All right, here, let's do that real quick. So, I mean, technically we kind of call the standard error the standard deviation for the problem, but yeah, going back. So this standard error, it has its own little formula. So either way, you're going to have to do math on this. And this formula is the standard deviation divided by the square root of n. So if we went back in and solved for s, we'd have to put 0.06 equal to s over the square root of 12. So basically to get s, you just got to multiply these two numbers. The standard error times the square root of 6. Again, do not round that number. You need it as accurate as possible because we only round when?
The final answer.
The final answer. Okay. So S is equal to whatever these two things are multiplied together.
It would be like, it's really long, but it's like 207.846. Yeah.
Wait, what does S stand for? Oh, standard deviation.
Standard deviation. Oops, that should be a 12, not an N.
Should be 0.06.
Professor, but if we use the table like we originally did and we used the formula that we just did, that we got the 3.42 and to 3.68, that would be right?
Yep.
Okay, that's perfect.
Yeah, it's much faster doing this by hand.
Yes.
Do you recommend doing it by hand instead of StatCrunch on the test?
Yes.
Okay.
So so I've got the number. I'm going to go back in and put this in StatCrunch real quick. So if we go in here and edit this, we should get the same answer. So if you get two different answers, then we know that we did something wrong because it should have been the same answer. So this is 0.2078460969. Now compute. There we go. There's the same answers.
Yeah.
Correct.
I think this is actually easier than doing it by hand.
Oh,
Yeah. It's
either way, it's all the same. Just make sure that you know what is what. All right, good catch on that.
Hey, Professor, you're gonna check if there's gonna be a table available on this particular
Yeah,
question?
I'll check.
Okay.
I will check. Let me pause this video and I will do a quick check of that. All right, so there's still more to part A because now in part A, we found the correct answer, which was C. Too high, which was C. We know what goes into our two blanks, the 3.42 and the 3.68. So now we got to talk about those answers that were incorrect and why they were incorrect. So explain the error choice for this one. We are 95% confidence that the sample mean is between blank and blank.
B.
Say it again.
B.
It is B. Yeah. The wording is incorrect because it talks about a sample mean. When we create this interval, it's not about the sample mean. It's all about the population mean. So definitely B. Plus, we already know what the sample mean is. All right. We are 95% confident that the population mean is between blank and blank.
D.
Sorry, say that again.
D.
D, yes. There's no error in that. That was actually the one we chose. And then the last one, there is a 95% probability that the population mean is between blank and blank.
A.
Okay.
Yep. Yeah, it should all about be confidence, not a probability.
Zoned out. So could you tell me again for the first one?
For which one?
For the first one after we did the math.
Okay, so after we did the math right here, we are 95% confidence that the sample mean is between blank and blank. We picked B because it references the sample mean. We already know what the sample mean is. We don't need a confidence interval for it.
Mm.
The second one after that, the 95% confident that the population mean is between blank and blank. There's nothing wrong with this one. That's why we chose D, because that's the one that we chose.
Mm-hmm.
And then the very last one, 95% probability. That's the problem right there. They call it a probability. It's not a probability. It's a confidence. Okay. And then part B, based on your confidence interval, would you believe that a population mean GPA of 3.57? Would you believe that the population mean GPA is 3.57? So the sentence goes, since 3.57 blank within the bounds. Is it within the bounds or is it not within the bounds?
It is.
It is. So the first blank is within our bounds. Because again, remember, we're looking at 3.57 according to this interval. And 3.57 is in here. So 3.57 is within the bounds of the confidence interval if blank is or is not plausible for the population mean GPA is 3.7.
Is.
I think that's supposed to be it is, not an if. So both of these blanks should be is. All right, here we go. Moving on. A statistics instructor randomly selects 4 bags of oranges, each bag labeled 10 pounds, and weighed the bags. They weigh 10.4, 10.4, 10.6, and 10.2. Assume the distributions of weight is normal. Find a 95% confidence interval for the mean weight of all bags. Use technology for your calculations. So this one is definitely technology A-OK. So is this with a summary or with data?
With data.
Are we going to be doing a z-test interval, or sorry, not a z-test, a z interval or a t interval?
T interval.
Good, because it's all about means. The z-tests only come involved when you're dealing with proportions. The t-test comes involved when you're dealing with mean. So in this one, it does say write integers or decimals rounded to the nearest thousandth. What's thousandth? How many decimals is that?
2 decimal places.
Eh,
3.
3.
it's 3 decimal places.
Sorry.
It's all right, Lewis. That's why I asked this question.
I
Just
always
to-
hate when they put like thousandth or like 100th. I'm like, oh my God, what is it?
It goes 10th, 100th, 1000th.
It's like, it's simpler to just say 3 decimal places.
Oh, is it, Lewis? What if it's simpler just to say 1000? 3 decimal places, I got to write 3 words. If I say 1000, that's 1 word. All right, so which one would we choose?
We would choose the one that refers to the population.
Which
So
is
B.
B. And when we fill in those blanks to the nearest 1000th, Lewis, what do we get?
I don't know if this is right, but
Me
I
either.
had 10.14. I mean, how many decimal places? 3, right? So 10.140 and 10.65. I mean 660 because it's rounded. Yeah.
Okay.
So 10.660.
Anyone want to agree or disagree?
I agree.
You agree? I agree too. All right. So again, how we did this, you just go into your stat crunch. I'll just call variable 1 oranges and what it was, 10.4,
10.4.
10.6, and then 10.2, right?
Yeah.
There's only 4 of them, right? So in here, then we go to stat, t-stats, 1 sample with data. Select oranges, confidence interval, and it's 95. And scroll down and compute. And there they are. You just got to do the proper rounding. Okay, so let's come back. We've got all of our information now. We got a question B here. So does the interval capture 10 pounds?
No.
Okay, so that means we're at B or D. So if I was doing a hypothesis test on this, would I reject the null hypothesis that the population mean weight is 10 pounds?
Yes, you would. Right?
There you go.
Because it's not included yet.
Yes. So which answer is it? B or D then?
D.
Say that again?
D as in dog.
Yeah, D. Just wanted to make sure because I know B's and D's sound alike. Yes. So you're going to say, no, it does not capture 10. And you're going to reject that because 10 is not in the interval. Good work. We are almost done. Almost there.
How many?
Remember, there are 25 questions on the final exam. Because remember, I told you back in the beginning that 5 and 6 are the same question. I don't know why I put the same, or well, I didn't make it, but someone made it and put the same question back to back. So this review only has 24 questions. But remember, 5 and 6 are going to be repeats on the actual one. So
That's like extra credit.
I know, right? You're welcome. All right, so 22. The US Department of Health has suggested that a healthy total cholesterol measurement should be 200 milligrams per deciliter or less. Records from 50 random and independently selected people from a study conducted by the agency showed the result in the technology output below. Test the hypothesis that the mean cholesterol level is more than 200 using a significance level of 0.05. Assume the conditions are met, so we don't have to worry about CL2. Okay. We've already done the CLT question. So which one of these is the null and alternative hypothesis for part A?
Is it C? Because it's more than.
Because it's more than. What's
It
the
says
rest of you think?
hypotheses that the mean cholesterol level is more. So yeah, I think so, right? C.
Yes, I agree with you. Because your null hypothesis is that it is 200, because that was the original claim right up here. That very first sentence, that is your null hypothesis. And then down below in that third sentence, it says test the hypothesis that the mean cholesterol level is more than. So that more than means greater than. So it is C. Good. All right, based on the information it gave you, what is the test statistic? It says round or write an integer or decimal. Do not round.
1.37.
Good job. That's just reading the output.
Mm-hmm.
C.
0.088.
Okay. Perfect. And then now we're on to the interpret. So we got a couple of blanks here that we're going to fill in. So the p-value is blank, the significance level, less than or equal to, greater than,
Greater than.
greater than. Okay. Blank, the null hypothesis.
Do not reject.
Do not reject. You sound uncertain about that.
I always get confused in this problems in the homework. That's why.
Yeah, do not reject or fail to reject.
Do not reject or fail to reject. Because again, when your significant or when your p-value is greater than alpha, that's when we fail to reject. All right, so there is blank evidence.
Was it insufficient?
It is insufficient this time.
And that's where I get confused all the time. Like I always get it wrong. Like there's like always.
If you reject, then that means you have evidence to show otherwise. Just like, in a trial, you're innocent, but if you find the guy guilty or girl guilty, that means there's evidence. If you find the person innocent, or in other words, fail to reject, that means there wasn't enough evidence. Does that make sense?
So every time that we see or choose rather to reject, then it would be sufficient.
If you reject, that means you have evidence to say that they're guilty or,
So in this case, it would be insufficient.
correct, because we're not rejecting. So there is insufficient evidence to conclude that the mean cholesterol level is blank. Equal to, more than, different from, less than.
Greater.
There's no greater than.
Oh,
choice,
sorry,
so it should kill
different.
them.
Yeah, different from.
Different than. Different than? No.
Is it equal to?
No.
More than.
More than. It's more than. There wasn't enough evidence to say that we would choose the more than, the alternative. Does that make sense?
Yes.
Yeah. So in other words, the original claim still has some validity to it. All right. 23. In country A, the population mean height for 3-year-old boys is 37 inches. Suppose a random sample of 15 3-year-old boys from country B showed a sample mean of 36.7 inches with a standard deviation of 2 inches. The boys were independently sampled. I feel like I'm missing something from that first sample. That's all right. Assume the heights are normally distributed in the population. Complete parts A through C. So part A, determine whether the population mean boy or mean for country B boys is significantly different from country A mean. Use a significance level of 0.5. So part A says, which one of these is the null hypothesis?
F.
We are trying to prove that they are significantly different.
So F, because it's not equal to.
I love it. Because when we are saying that they are different, we are saying they are not equal. Good. Okay, moving on down. Now we got to find this information. All right. So go into your calculator, or not your calculator, but go into StatCrunch and run this. Is this a 1 sample t-test or a 2 sample?
2,
Nope.
1.
Can you go
So
up
one
to
sample.
can you go up to the question, the original one?
Oh, yes.
Yeah, thank
All
you.
right, that was weird. It is a 1 sample t-test.
So that
Okay.
means it's paired, it's dependent.
No. It's a 1 sample.
Oh, okay.
There was only 1 sample taken. And also, if you look at this, notice your null hypothesis and alternative, it says mu. It doesn't say mu1, mu2, or mu diff. If you have a 2 sample, you will see mu1, mu2, or you will see mu diff for a 2 sample. Okay. This is a 1 sample. There's all of your information.
So Professor, I have a question. Which mean would we use then for this? Would we use the 37 or the 36? I mean, it's kind of the same thing. It's 36.7 is like rounded up, right? So like, can we use like 37 or 36.7 to plug in the stat
All
crunch?
right, let's go. Let's go to StatCrunch then. So we're going to StatCrunch. We are doing T-stats, right? T-stat. 1 or 2 sample again?
One sample with summary, I believe.
With summary, because we don't have any data.
And now I see that it says sample mean, so yeah.
Now you
36.
know now you know which one goes where.
Yeah.
So what goes in sample mean?
The 36.7.
What's the deviation?
I believe it was 2 or something.
Let's make sure.
Yeah, 2
Deviation is 2. Good.
and 15.
That's the wrong one. 2, 15. What goes in for 0?
The 37.
Yeah, hopefully that's the same that you were selecting from F. This should look just like your choice F. And we did the not equal, and now we compute. Now we've got everything we need. Okay?
Yeah.
So let's go back to our calculator, or let's go back to our exam review. So the T statistic is write an integer or decimal rounded to 2 decimal places. The p-value is right an integer or decimal rounded to 3 decimal places. So what is our t-value?
Negative 0.58.
Negative 0.58. Good, because it's 2 decimal places. What is our p-value? 3 decimal places.
0.571.
Okay. All right. So our t-value, again, from what we just looked at, negative 0.58, p-value 0.571. Okay. So now let's talk about this. It says, are we going to reject or fail to reject?
Fail to reject.
Fail to reject. So that means it's either B or D.
Is it B?
Is it B?
I would say B.
Wait, did you say you're rejecting?
No, do not reject.
Oh, do not reject. Yeah. So B?
Yeah, because the p-value is higher, so it's do not reject, but I'm confused with the wording.
Yes, the wording, because one, the big difference is one says there's no reason to believe it's not, and one says it is definitely 37.
I would say it's B because I don't think we would be like that sure. I don't know. It sounds weird. I would choose B.
Yeah, I agree
And
with
it is B. So again, the reason behind that is you're not proving this. When you say something is definitely this, that means you proved it. We didn't prove anything. We just found that there is insufficient evidence to think otherwise. Does that make sense?
Yes.
You didn't prove it's 37. We just didn't have any evidence to say that it's not. So there's no reason not to believe it. Make sense?
Yes.
Yeah, because we didn't prove anything. All right. So now part B.
So we changed the sample size.
So now suppose we have a sample of 30 boys. Repeat the test. Well, that's easy. We're going to go back here, click on options, click on edit, and change the 15 to 30. Compute. What is let's go back, let's double check.
2 decimal places.
2 decimal places and then 3 decimal places. So the same as what we did a second ago.
Yeah.
All right.
So
What is the T?
negative 0.82.
Okay.
And
What is P?
0.418.
Okay.
And same thing with the p-value because it's still higher. So
Okay. So do we reject or do not reject?
we do not reject.
Not reject.
And is it C or D then?
D.
D.
Yeah.
Because again, we didn't prove it was 37. We just had no reason to doubt it. Okay. All right. Part C. Explain why the T value and the P value for part A and B are different.
When the sample size is bigger, the p-value gets smaller.
Correct. That is true.
So a larger n causes a smaller p-value. But it's talking about the standard error, so
So is it A?
So you said first, a larger sample causes what?
A smaller standard error?
No. Louis, what'd you say a second ago? A larger sample causes a what?
A smaller p-values is
So
either,
that means it's either C or D.
yeah. Uh, is
C.
C?
Say it again.
Is it C, like narrower sampling distribution?
Okay. Because the larger N causes a smaller standard error, right?
Yes.
Yes, that is right. And the smaller your standard error, the less area that's going to be under your tails. Okay. So it is C. The larger the N, the smaller the standard error, the smaller the p-value. Because remember, when we looked at this, the larger our N was, the more it mimicked the normal curve. And the more accurate it became. The more information you have, the more accurate you're going to be. All right. This is it. Number 24.
Oh,
Um,
that's long.
Yeah, I don't want to put that in.
Oh, okay. Here, Mr. Armstrong, can you just put it in for us? All right, I'll go in, I'll put the information in, and then you tell me what to do. All right, how about that?
Okay.
All right,
Thank you,
so
appreciate it.
I'm gonna keep that information though on the screen. And I'm gonna slide over my stat crunch over here so I can look at both at the same time. All right, so this, obviously this one should look familiar. We are dealing with two samples here, right? So this is where we need to know, are they independent or are they paired? What do you think?
I think that these are independent
Yep,
Why?
agree.
because it says were
Independently.
obtained independently and weighed.
Well, that's all right, but I mean, that's one thing we got to check no matter what. But
Also
why are
because
these?
our example in the when you were teaching us, it was this one and it was independent.
Oh yeah, okay. So the example I taught you, because it's independent, this one's automatic. No, it's because these two groups have nothing to do with each other.
That's true.
The weight of a baseball player has nothing to do with the weight of a soccer player. One does not affect the other. Knowing the weight of a baseball player tells me nothing about the soccer player. Does that make sense?
Mhm.
Yes.
They're not the same people. It's not the same concept. So 204 through the first column with baseball. Yeah, so this is going to be kind of your longer one. Most of the time, what takes you the most time in this is when you go into StatCrunch and have to put data in. That's usually what drags it out. All right, baseball is done. And remember, when you're taking this exam, you should be able to send all of this data over to StatCrunch right away because you'll have that little symbol that follows by the data that you have seen in your assignments and you've seen in your quizzes. So you're not going to have to type out all this information like we are having to do right here because you can send it directly into StatCrunch. All right, I've got everybody. Okay. So reading this, it says that we got a random sample of male college baseball players and a random sample of male college soccer players were obtained independently and weighed. The accompanying table shows the unstacked weights in pounds. The distribution of both data sets suggests the population distributions are roughly normal. That's good. Determine whether the difference in means is significant. Use a significance level of 0.05. All right. So obviously you can see here that this is definitely a 2 sample because you see 2 samples here, a mu1, a mu2. So the question is, what goes in that first blank?
Equal.
Perfect. And then for the alternative, what are we testing when we ask, are they significantly, what does it say? Whether the difference in the means is significant. What are we testing there?
Not equal to?
Not equal to. Perfect. So that looks like this information right there. Equals for the first blank, not equals for the second blank. All right, now they are asking about the t statistic, round to 2 decimal places, and the p-value. Round to 3 decimal places, just like before. Okay, so let's go out to StatCrunch. Where am I going to go?
Stat. T stats. 2 sample
Good. Because this is independent
with data.
with data. All right, who's sample 1?
Baseball.
Baseball. And sample 2
Soccer.
is soccer. Again, just to double check this, how I know that, look at your information here. Baseball is first, soccer is second. So this is 1, this is 2. That's how I know it for sure. I'm not taking a guess there. And then we are doing a hypothesis test where it's 0 and not equals. So it's set. What is our t-stat to 2 decimals?
4.59.
Perfect. P value to 3 decimals.
0.000.
Good. Okay.
So we will be rejecting.
Oh, all right. She's on top of it. So again, here's our t-stat, 4.59. P-value, 0.000. Okay.
Then sufficient evidence.
All right. So coming back in here, we're almost done. Oh, wrong one. So what is the conclusion for this test? So blank, the H not.
We're
Reject.
rejecting.
Reject.
And there is sufficient.
There is sufficient evidence. And that, my friends, is the final exam, exam 3 review, chapter 7, chapter 8, chapter 9. Any last minute questions?
I thought you said it was 25 questions.
What did I tell you about one of them?
Remember
Oh, yeah. I
Yeah.
forgot.
Yep. Okay. I'm going to stop the recording.